Hello students, welcome to the class of software engineering. Let us now discuss about software processes. First, let us see what is a software process. What is a software process? A software process is nothing but a sequence of activities that leads to the production of a software product. So, what is a software process when I tell? It indicates the activities which perform during the development of a product. Okay, so it is a sequence of activities. So, those activities are performed that leads to the production of a software product. So, software process is a sequence of activities mainly leads or which mainly results in a software product. So, it's like how it mainly specifies how you're going to develop the product. The activities in software process are: first one is software specification, second one software development, third one software validation, fourth one software evolution. We will discuss about each one. So the first activity in software process is software specification. So this is the first activity. So what happens in specification? Here is actually the customers or the clients, they approach the company and they speak with the software engineers there, isn't it? So they actually define the software that is to be produced. So they actually give the requirements, what kind of software should be produced, and also the constraints. Constraints means some restrictions or some limitations can be there. Okay, so they are going to define all those requirements. That means what your system should do. They must say what functionality should be there in the system, what services the system should provide, and what are the constraints. So all those comes under specification. So it's nothing but specifying the requirements, specifying what your system should do, what functionality it should provide. Second one, software development. Now, what is this development stage? Where you're developing your software. So, how you're developing? You are designing your software and also doing the programming. That is, you're writing a source code. So, that is development stage. So, development stage is where you're doing the implementation of your system. So, that is either through coding. So through programming. So you can use any of the programming language. Next, software validation. Now after development, you need to validate the software. So validation, the term is validation. So what does it mean? You have to check once it has been developed, you have to check your software to ensure that it is what the customer requires. Means you need to check whether your software works exactly as the customers have specified in the early stage, that is in the specification. So you need to check whether your software will satisfy all the requirements that has been given by the customer and it works correctly. So that is validation. Third activity is validation. Fourth one is software evolution. What do you mean by evolution? Here, still your software is modified. Why it is being modified? You have developed it. But why you're modifying it? That stage is called evolution stage. Evolution stage. So what happens in this evolution stage is you are going to modify your software, or it's like updating. Why you're doing is because you know that the business needs keeps on changing day by day. As new technologies emerge, the business requirements keep on changing. So in order to reflect those changes, we are modifying the software. Okay. So based on the changing customer requirements. So these are the activities in a software process. First one, specification, second one development, third one validation, and fourth one is evolution. Next, we'll see what is a software process model. Earlier, we had seen what is a software process. Now, we'll see what is a software process model. So, we'll see the different types of software process models here. So, first, let us see the definition. A software process model, okay, is a simplified description of a software process that presents one view of that process. So, this software process model is just a simplified description of software process. So, you know what is software process? So, this software process model will represent a simplified description of this software process. So, it will present in one view. Within one view, everything will be presented. So all within one view only, all the activities will be presented here. So that is software process models. The types of software process models are: first one, workflow model. Second one is a data flow or activity model. And third one is a role or action model. Now we'll see a workflow model. What is this workflow model? This shows the sequence of activities in the process along with their inputs, outputs, and dependencies. So, in this model, workflow model, it will show the sequence of activities involved in the software process. Along with, it will specify what inputs have been given to the system, what are the outputs, and what is the dependency factors. Okay. The activities in this model represent human actions. Next, second one, a data flow or activity model. So, what is this model? This represents the process as a set of activities only, each of which carries out some data transformation. So, but it shows as a sequence of activities only, but each activity is going to carry out some data transformation. Means it shows how the input to the process, such as a specification, is transformed to an output, such as a design. So it mainly shows how the input to the process which you have given. Okay, input is nothing but the specification. You are specifying the requirements. That is the first stage. So that input, if you give, you get the output. Means once you define all the requirements, you can design your system. Next step is you can design your system. So output is design here. Clear? So input is specification. Nothing but you are specifying all the requirements. So once all the requirements have been collected and analyzed, you can start designing your model. Okay. The activities here may represent transformations carried out by people or by computers. The activities here may represent transformations carried out by people or by computers. Third one is a role or action model. So this model actually represents the roles of the people involved in the software process. So this model mainly explains the roles of the people involved in the software process and the activities for which they are responsible. So just a role or action model will actually specify the roles of the people involved in the software process. So these, and also it specifies the activities for which they are responsible. So these are the three types of software process model: workflow model, data flow model, a role or action model. Now we'll begin with first software process model, that is waterfall model. So this is very important, waterfall model. So the term, you can see waterfall model, you have this diagram. This is the diagram. And By looking at this diagram, you can see why the name waterfall is given. Waterfall, the name sounds good. So here, because of the cascade from one phase to another, it is called waterfall model or software life cycle. So this waterfall model is also called as software development life cycle. In short, we call SDLC, software development life cycle. SDLC. Okay, now why this name came waterfall is when you look at this diagram, you can get to know that there is cascading from one phase to another. Like they are the steps from one step to another step. You can move from one step to another step, isn't it? You can't jump from one step. Even in the steps in the staircase, if you consider, you you cannot jump directly, isn't it? You might fall. So from one step to another step you have to go. So same thing, from this step to this step, then from this step to this step only you can go. So there is cascading from one phase to another. Because of the cascade from one phase to another, this is called as waterfall model. Okay, this is called as waterfall model. Now we'll begin with the phases. Which are the phases? Okay, can you see the first phase is requirements definition. First phase is requirements definition. Now it's nothing but, you need not confuse, I have told specification. So it has the same meaning, specification. This is also called as requirement specification. So here what you are doing is you are actually specifying what your software should do, what services it should provide, what services it should provide. And also you are going to specify the all kinds of requirements here. Okay, and it's nothing but you're specifying the goals, what your system should do, what functionality it should provide. Okay, specify the goals or constraints. See, constraints means what? See, these are restrictions, you can tell. Some of the restrictions or limiting factors in your project. So keep in mind, we are using this word throughout our software engineering. Constraints means they are the restrictions or limiting factors in your project. So it can be, we have technical, business, design constraints all. Okay, so several type of constraints are there. You need not worry about this. Some example I can tell. If I talk about technical constraints, see, the customer might tell you to develop the software in certain programming language. Like for example, in Python, he will ask to implement. He puts a constraint. It should be implemented in Python only, not any other programming language, not a programming language which is of wish of the software developer. So it's a constraint, isn't it? Because there might be the reason that the customer knows well, he's very knowledgeable in Python, you think. So that's why he has given that constraint. You have to develop it in Python. But the software developers might be very adaptable to some other programming language. Okay. But there is no choice, they have to implement in that. Then use of some libraries. Some companies will tell you, some clients will tell you can use open source libraries. But some other clients, they may not agree with that using of open source libraries. So they will give a constraint, don't use the open source libraries, like that. Then there are business constraints. This is very easy. Business constraints are like the client will actually tell about the product, but also will tell what is the budget, so what might be the cost. So there is a budget constraint. So within this much budget you have to develop the software. So they might define the budget. So they might tell that within this budget you need to develop the software, so the budget should not cross it. So that might be one constraint. Another one is schedule. So they will fix a date, isn't it, when this software should be delivered. So that is one of the constraint. Like within 1 year, you have to, for example, they might tell within 1 year you need to develop the software, deliver the software to them. So the target here is only 1 year. So that is the schedule constraint, I can tell. Schedule constraint. So these are called actually constraints. So in requirements definition phase, you are going to specify all the requirements of the system. What are those requirements? They are going to tell what your system will do, what your system should do, what services it should provide, what functionality it should give. So also it will specify the constraints also in the requirements. Okay. Now, in that phase only, you have to also analyze these requirements. It's just not noting down all the requirements. You need to analyze it and understand it, and you need to think about whether it can be implemented or not. So, analyze these requirements means you have to analyze all these requirements in order to understand it clearly, and whether you are able to implement it. You need to see it. Okay, second phase you can see is system and software design. System design and software design. So what does it mean? System design means those requirements which we have analyzed are partitioned to hardware or software requirements. Okay, that is the meaning of system design. System, see, when I tell system design, it means what all requirements you have identified in the first phase, okay, that you have analyzed it also, isn't it? You have analyzed it. So you need to partition it into hardware or software requirements again. So the whole set of requirements, you have to partition it into hardware requirements and software requirements. What do you mean by software design then? Software design means you're developing an architecture for your system. Developing an architecture for your system. So that is the second phase. You can see here, system and software design. Third one is implementation and unit testing. Implementation and unit testing. So what do you mean by here? Implementation means you are implementing, that is developing your software. So using some programming language, you are developing the software. And unit testing, so once it is developed here, unit testing means each component or each unit, you are testing it to check whether it meets its specification, whatever its functionality. You need to see. So unit testing means you have several components in your system. So you are testing each component to check whether it works correctly, one thing, and it works exactly as specified in the requirements. Okay. Fourth one is, you can see fourth phase, integration and system testing. What is this? Integration and system testing. Integration means those individual units or modules, all those are integrated into a single system. So you get a single system which is your final system, I can tell. So all those programs or units or modules are integrated into a single system or final system to ensure that the software requirements have been met. So you are now testing the entire system. Why are you testing the entire system? To see that whether it works correctly or not. And after testing, that software is delivered to the customers. That software is delivered to the customers. Clear? Okay. So that is integration and system testing. And the last phase you can see is operation and maintenance. So here you have unit testing, testing each individual unit. Here you are testing entire system. Now operation and maintenance is the last phase. Operation and maintenance. Let me see now. This is the longest life cycle phase. This is the longest life cycle phase. Why it is longest? Can you see in the diagram? If I start You can see this length, how much it takes. So this is the longest life cycle. But how come? See, you might be thinking after developing the software, you deliver it to the customer, your work is done. No, the work starts from there. What is that? Maintaining your system. So you know that maintaining your system is a very difficult process. You need to maintain your system for several years, and the cost here required for maintaining is also very huge. So here in maintenance phase, it's nothing but, sorry, in operation stage, it's nothing but the system is put into operation. So the system is installed and put into use. That is the meaning. The system is installed and put into use. What is maintenance? It's nothing but correcting the errors or making changes to your software. Okay, in order to correct the errors that were discovered in earlier stages of life cycle. Okay, so either you're making the changes to the system, doing any modifications, or it can be updation. Okay, so that is based on the changing business needs. So making changes after the system has been developed is expensive. It's expensive because entire system has been developed already, isn't it? Entire system has been developed, so it's very difficult. So this is about the waterfall model. Waterfall model. So we'll see the advantages of waterfall model. Advantages of waterfall model. This model is simple, very simple and easy to understand and use. This model is very simple and easy to understand. And it is easy to manage due to the rigidity of the model. What is that? Each phase has specific deliverables and a review process. So here actually each phase will have some deliverables, some like it's like some outcome or some result. Each phase will be producing some outcome. So like for example, requirements definition. Here you're collecting all the requirements and analyzing it, correct? So final output, what do you get is a requirements document. What is that? SRS will be ready now. SRS will be ready. So that is a deliverable. Some working result. Working output also I can tell. Next, system and software design. If I tell, the designing part of your system will be ready now. Clear? Implementation and unit testing, in the sense the code part, source code will be available. So each phase has specific deliverables. In this model, phases are processed and completed one at a time. Keep in mind, in this model, the phases are processed. So it is first the requirements definition stage only. Then only once you complete this phase, then only you can move to the next phase, system and software design. Okay, it's not that once you complete this phase, you can jump directly to operation. No. So phases do not overlap. I can tell phases do not overlap. Waterfall model works well for smaller projects. It works well for smaller projects where requirements are clearly defined and very well understood. So this model is suited when the requirements are very clear and they can understand the requirements easily. So you can choose this model for building smaller projects. You can choose this model for building smaller projects. So these are the different advantages. Okay, keep in mind that this waterfall model is works well for smaller projects. So here actually the requirements are clearly understood. Next, we'll see the disadvantages of waterfall model. See, once an application is in the testing stage, it is very difficult to go back and change something that was not well thought out in the concept stage. So it's like, suppose I'm in one stage of the software development life cycle, like I'm in testing stage. I have developed my software. Next, I am in the testing stage. So, if I want to, suppose I've got some error, you think, and now I want to resolve that error. So, I need to make changes. So, is it possible or not in the waterfall model? It is very difficult because you need to go back. That is the thing. You need to go back to that phase and change something. So it's like you need to go back to implementation. Before that, you need to go to design phase and change also, isn't it? So it's very difficult. Second one, no working software is produced until late during the life cycle. So no working software. See, actually here you get some deliverables, I've told. Deliverables are nothing but here just the documentation you get here. I'll just tell. See, from requirements definition, you get the SRS, na? You get the SRS as a document. Okay. From system and software design, I can tell some design models you get. Implementation, you get the source code. But you don't till this stage, okay, till this stage you are not getting any working product. When you'll get after the system testing, when yeah, you get the working product. So it's very late, isn't it? Very late. You don't get in the early stage. You don't get in the early stage. So no working software is produced until late during the life cycle. So once all the phases are complete, then only the working software is produced. Third one is high amounts of risk and uncertainty. So there are chances of more risk in the project. So about risk, we'll see in detail later. So there might be high amounts of risk associated with the project. Fourth one is not a good model for complex and object oriented projects. So this is not a good model for very complex project and also for object oriented projects. And it is a poor model for long and ongoing projects. So if the project is very long, then this model is not suitable. And also it is not suitable for the projects where requirements are at a moderate to high risk of changing. So if the requirements are at a moderate to high risk of changing, then this model is not suitable. So these are the disadvantages of waterfall model. So if you are in the testing stage, you cannot go back to the previous phases. It's difficult to go back to the previous phases. Okay. And no working software is produced until late during the life cycle. There is more risk, and this model is not suitable for very complex and long projects. Next, when to use the waterfall model? When can you use the waterfall model? See, first point, the model is used only when the requirements are very well known, clear, and fixed. So, if the requirements are very clear and it can be understood properly, and also it is fixed, it doesn't change. At that case, this model can be used. Second one, product definition is stable. So product definition is stable, it doesn't change. Third one, technology is understood. If the technology is understood, you can use this model. Fourth one, there are no ambiguous requirements. There are no conflicting requirements. So requirements are very clear, complete, and consistent. Fifth one, ample resources with required expertise are available freely. So resources are also there and the expertise is also available. Then you can use this waterfall model. And another thing is the project is short. So for small projects, this model is better to use. Okay. Now just we'll see a simple example for waterfall model. So here there are some examples of waterfall model. We have HRM, that is your human resource management, retail chains, supply chain management systems, CRM. For all this purpose, these examples, the waterfall model is being used in order to build such systems, HRM, retail chains, all those. Okay. Now we'll see what is a risk. So I've told about risk. Now we'll see what is a risk. So I've told in waterfall model that you can there is a high amount of risk associated with the projects. That is one disadvantage. So what is project risk? So it is nothing but risk associated with your project. So that is nothing but an uncertain event or activity that can impact the project's progress. So it's an uncertain event, I can tell, or activity that will affect your project's progress. So the impact here, what I'm talking, can be positive impact also, negative impact also. So let us see here the different types of risk in detail. So now we have understood what is a risk. So it's an uncertain event or activity that can impact your project's progress. So first category, there are primarily three categories of project risk. First one is organizational risk. So it is a risk related to your human resource or your testing team. Okay, so organizational risk is related to your human resource or your testing team. For example, in your project, lack of technically skilled members is a risk. So that is one risk. It's going to affect your project's progress. See, if there are not enough skilled people, then we cannot tell that our project can be developed successfully or can be developed within the given period of time. It can extend for many months also, I can tell. So it will be lagging, your project will be lagging. So lack of technically skilled members is one risk which you have to consider in your project. Not having enough manpower. So very good manpower, and if you don't have that, then to complete the project on time is another risk. So that's why I told you, your project cannot be completed on the given time if there is no enough manpower. So that is also a risk. So now we have clearly understood what is a risk in the project. One is lack of technically skilled people is a risk, and not much manpower is also another risk because you won't be able to complete your project in the given time. Second one, we'll talk about technical risk. Technical risk is the probability of loss incurred during the execution of a technical process, such as untested engineering, wrong testing procedures. So these all risks are associated during the technical execution of a technical process. So it's related to technical thing here. So like suppose you're doing testing process means, and if the procedure is only wrong, then that is a risk to your project. Okay. We'll take one example. See here. Here first conversation. Our company reported a big loss this year. I must cut off your project budget by half in next month. So what happened? The company has gone into a big loss for the particular year. So he's telling he will cut off the project budget by half in next month. So here the person tells it's a bad news. How can I manage the project with such low budget? So see now the risk how it is. Okay, thing was company went in loss. That was one of the risk factor. Company went in loss. That is one of the risk factors. So now what happened? The budget has been reduced. So once the budget has been reduced, it's very difficult to finish up the project within that budget. I know, but we have no other choice. Please find a solution to deal with it. So these are type of risk. Okay. Third one is business risk. This risk involves an external entity. Like it is the risk which may come from your company, your customer, but not from your project. So this is the business risk, which this example is for business risk. Okay. So this risk involves an external entity. It is the risk which may come from your company, your customer, but not from your project. The risk is not from your project, but it's from the company or your customer. So this example actually specifies business risk. Business risk. Next, we'll see about the incremental model. So we have seen earlier waterfall model. Next, we move on to incremental model. So this is the representation of your incremental model. So you have outline, description, concurrent activities. So we'll begin with this incremental model. It is based on the idea of developing an initial system. So it is how it is different from the waterfall model. Let us see. See here, it is based on the idea of developing an initial system. So you have an initial system, exposing this to user comment, making it exposed to user comment. So users can comment, give feedback, give suggestions, making changes and developing several versions until an adequate system is formed. So you can see you're making changes and developing it till you get different versions. Finally, you have to reach to a complete system. So here, what can you notice here is specification, development and validation activities are interleaved rather than separate activities. So what can you see here is this is the outline description of the system. And what do you observe here in this model is specification, development and validation. These three are interlinked. Okay, so they are running as concurrent activities parallelly, or they're running simultaneously. So that's why it's mentioned here concurrent activities. So they're running parallelly. So they're not working as separate activities like in a waterfall model. First, you have specification. After you complete the specification only, you're moving to the development stage. No. But in incremental model, this doesn't happen. All these are interleaved. They're working parallelly. So this model is better than waterfall model for most business and e-commerce. For most business and e-commerce. So whenever a problem statement is given, it's the tendency that we try to solve it in a series of steps. And then when we do backtracking, we realize that mistakes have been made. That obviously happens. See, you try to solve a problem, okay? So you solve the problem, you have done several steps. Like imagine one mathematics problem you have. They have given to you to solve it. It is for 10 marks. Imagine what is the complexity. Might be you have the steps also might be 10 steps might be there. Now you have reached till the 10th step and you found that the answer is wrong. Then you have to go back, isn't it, and see which step where went wrong. So that is the same thing here. We do backtracking, we realize that mistakes have been made. So in waterfall model, if you think like that, backtracking is very difficult. Okay. So here, by developing the software incrementally, now we are in this model. The model name is incremental model. So that means that we are developing the software incrementally. So here you can see that first you have initial version, then these are intermediate versions, and this is the final version. So it's nothing but the final system. So what you are doing is you are developing the software in increments. So first one initial release. So you are doing specification, then development, you're developing it and validating it. That will be your initial release. Next, again, you are taking next specification. This is first specification. So first specification is nothing but first requirement, which is going to provide some functionality, and that is called as here increment. So I'm developing one increment. So first I'm specifying it, developing it, and then validating it. So I got initial version, one increment. Next, intermediate versions, many other like that. Again, a new specification, we are trying to develop it and validate it. You get like this several versions, and finally you will reach to an adequate version. Okay. So here the software is developed in increments, so it is cheaper and easier to make changes in the software. So each increment or version provides the functionality that is needed by the customer. So as I've told that here you are doing specification. So you are taking one specification is nothing but one requirement, or you are trying to develop one increment. One increment is going to provide functionality which is being given by the customer. Now, early increments usually include the highest functionality. Now, here also, you might be having several increments to implement. So, which one to choose? That is important. The increment which is having highest functionality, that will be developed first, and lower functionalities all later you can develop. Okay. So, initially you develop the increments which is having higher functionality. We'll see the advantages of incremental model. First one, the cost of accommodating changing customer requirements is reduced. Here the cost of making the changes, okay, that is reduced. The amount of documentation that has to be done is much less than is required with the waterfall model, because in waterfall model every phase will provide a document active. So but it doesn't happen in incremental model. Every phase doesn't provide document here, so that is reduced. One is cost of making the change is also reduced. Second one, it is easier to get customer feedback on the development work that has been done. So this model is easier to get customer feedback. How is it? See, you develop one increment, isn't it? That increment you can give to the customer and they can check. Customers, they can check it, they can use it, either they can test it, and once they test it, they can comment on anything, like they can give feedback regarding it. They can comment on demonstrations of the software and see how much has been implemented. So one thing is they can get a demo of the increment, so they will get to know what has been implemented and whether it is correct or not. They can give some suggestions also to the developer to in order to make it more better, and they will also get to know uh, they are in which stage of the project progress. Okay. And third one, rapid delivery of the software. Then your waterfall model, there is rapid delivery of the software. Since you are developing in increments, that is the reason. Next, we'll see the disadvantages of incremental model. Here, disadvantage is the process is not visible. You cannot see the process actually here. It's not visible because first increment will be developed, specification development and validation all will be running parallelly. So managers need regular deliverables to measure the progress. Now, thing is the manager finally has to give the report. So per week what has been done, he cannot get to know. So actually how we'll get to know by the deliverables. But here there is not much deliverables. Deliverables means here the report or the document. So not much of documentation is there. Second one, you know that if you keep on implementing new changes, that is adding new increments, then the structure of your system starts to degrade. And also there are chances of corrupting the software. Next model we'll see is reuse oriented software engineering. reuse oriented software engineering, or it's also called as component based software engineering. So it's also called as component based software engineering, CBSC in short we call. So by this term itself, you can get to know that this is based on reuse concept. It is based on reuse concept. So this is the diagram for your reuse oriented software engineering. We will go into detail regarding it. So what are the stages involved here? First one you can see is the requirement specification. Already you know about this one. You are specifying all the requirements of your system. So I won't go in detail regarding it. Next stage will come to is component analysis. What do you mean by component analysis? See, once we have the requirement specification, a search is made for components to implement that specification. Okay. So here component analysis means now you have the requirements with you. You have specified the requirements. A search is made for components to implement that specification. So third one you can see here is requirements modification. So here once the requirements are analyzed, using the information about the components that have been discovered in. So you know that you have specified the requirements and you are searching for the component that can implement the specification. So once the requirements are analyzed, using the information, now you have got the component. So using the information about the components that have been discovered, again requirements might be modified. Why? To reflect the available components. You are modifying the existing requirements. If requirements cannot be modified, you think, then you have to go back to again component analysis stage. You have to go back again to component analysis stage, okay, and search for alternative solution. So if you cannot do the modifications, then you have to go back to component analysis stage and you have to search for alternative solutions. Next stage you can see is the system design with the reuse. Now the term comes reuse. So what does it mean? Here the framework of the system is designed. The framework of the system is designed, or reuse means existing framework is reused. So either the framework of the system is designed newly or some existing framework you are taking and you are reusing in your project. So while designing, some reusable components are used and or some new components also might be added. So you might be having new components as well as some reusable components. Next we have development and integration. So here reusable components and framework both are combined together in order to create a new system, that is integration. Reusable components and framework. So both are combined together to create a new system. So here integration, notice that integration is part of the development process, not like your waterfall model. Here the integration is part of development process and it's not a separate process, not a separate process. So that is about the CBSC. And finally, system validation, you need to validate your system. Now we'll see the advantages of CBSC, component based software engineering. One thing is it reduces the amount of software to be developed because some you're reusing, isn't it? So it will reduce the amount of software developed. It will reduce the cost, also the risk. So there are no more, not much errors might be there. Okay. Second one, faster delivery of software, because if you are using the already existing codes, reusing that, then there is faster delivery of the software. Now we'll see the disadvantages. Disadvantages. Now requirements may not meet the real needs of users. Now the requirements may not meet the real needs of users. So Since you are reusing, we cannot tell that whatever component you have built might completely satisfy the requirement given by the user. Okay, so that is one. May not meet the real needs. Second one, because it is reusing, so somewhere it cannot exactly meet the requirement. Second one, some control over the system evolution is lost because new versions of reusable components are not under the control of the organization using them. So some control over the system evolution is lost. System evolution means suppose you want to make changes after it has been developed or during the maintenance phase you want to make changes, then reason is that is lost, the control is lost because new versions of reusable components are not under the control of the organization. Those reusable components are actually not under the control of the organization using them. That's why. So it's difficult to update or modify the system. So these are the disadvantages of CBSE. Thank you.